Alright, well, the slope of a tangent line comes from the derivative, and to have a horizontal slope, you want the derivative to be 0. So we're going to need to find the derivative, set it equal to 0, and then solve for what time that happens. Solving for a horizontal tangent line is very common. So we've got something over something, so I'd start off with quotient rule. Quotient rule says take the derivative of the numerator, so bring the power down, lower the power by 1, and then derivative of the inside for chain rule. Oops. Times the denominator left alone. Then minus the derivative of the denominator, which would just be 1, times the numerator left alone. All over the denominator squared. So it looks like we only needed chain rule the once that I did there in red, but we needed quotient rule to be able to do that. And then trying to make this look a little bit neater, I guess I could move this to the bottom of its fraction. Oops, 3t. And then over here I could move this. Oh, well, this one I don't want to move because it's not a negative exponent, just the square root. And I guess we could start looking for answers. Since this is a circuit and there's a limited number of answers to pick from, you can probably tell which one it's going to turn into. But I fully suspect I'm not even ready to really check because complex fractions almost always considered unsimplified. Got a smaller fraction within a bigger fraction. So what I really want to do is multiply this fraction by its denominator, so that stuff cancels. But mathematically, we can only do that if we multiply everything by the same thing. So if we were to do that, the aftermath of these two canceling would be 3t. If you multiply these together, you end up with a negative 2. The square root of something times the square root of itself just gives you that stuff. And all that on the bottom. Then it looks like up top, if I distributed this, 3t minus 6t be negative 3t. Negative 2 times negative 2 is 4. I don't think I'm going to do anything with this denominator, but that's where I would start to look. I don't see anything that looks like that, so I'm overlooking something. Oh, yeah. I spent so much time finding the derivative that... Okay, so then in the end, horizontal lines have a slope of 0, so I cared about where does this guy equal 0. But since I got this common or complex fraction dealt with, I got one big fraction, and a fraction equals 0 when the numerator equals 0. So in the end, we're really just solving this. So it looks like when t is 4/3, we make this 0, which is the derivative, and when the derivative is 0, is when you have a horizontal tangent line. And I see 4/3. Yeah, that's what I got. That one's on the front page.